This question is about completing the square. We've got a quadratic expression on the left, and then suddenly we turn it into a square, but there's like an extra little bit at the end. We'll come back to where that little bit comes from. But what we want to do essentially is try and create a square that we've got x here, and we've got x here, and then we've got numbers. So it might be like +1 and +1. They have to be the same to create a square, but we want that to get as close as we can to x squared plus 10x plus 29. I'm going to get rid of the ones for the moment. So x is the starting point because that is going to give us an area here of x squared, and we've dealt with this. So how am I going to then get 10x? Well, I need this number here to be the same as this number here, and I want these two areas to add up to 10x. The way to do that is to make them the same is to halve that 10x. So this is going to be 5 and this is going to be 5. And that means that this area here is going to be 5x and this one is going to be 5x. And I again have this one here, 10x. So I've sort of created a square. So currently I've got x squared plus 10x. Now what I've got left over that I just have to have is that I get 25. Just this extra little bit. So what I've essentially done is I've said that x squared plus 10x is equal to x plus 5 squared. Okay, because that's what this thing is here if I multiply x plus 5 by x plus 5. But then I need to minus this 25. I'm nearly there. That means that x squared plus 10x plus 29 is going to equal the same thing as before, x plus 5 all squared minus 25 plus 29. And now I just need to add these two numbers together. So that will give me x plus 5 all squared and then plus 4. So I've done it visually to try and show you where the halving comes from. You basically need to put the x in, you have the 10, that gives you your plus 5 and your plus 5. You get an extra little bit, which you will then need to subtract if you want just the x squared plus 10x by itself. But I've just had to deal with this constant at the end. If I was to do this non-visually, then I would say, right, I know I need to have the 10, so I'm going to get x plus 5 squared, because that's going to give me my x squared and my 10x. I'm going to need to minus 5 squared, or 25, to keep it the same. So I've just got x squared plus 10x. I'm doing the same thing as before that I was talking about visually. I've still got my plus 29, so I need to include that. And that will then simplify to that. So you can straight away write this one line down and get the answer, but I've tried to show visually what's going on. And this is why it's sort of called completing the square, because I need this extra 25 to complete this square structure. All right, 1 mark, write down the coordinates of the turning point of the graph of y equals x squared plus 10x plus 29. This links strongly into part A. And so you probably either know the answer to this or you have no idea. But what we have here is a quadratic, and it will look a bit like this. I don't know whether it goes through the axes at this point. It might not even go through the axes at all. It might be up here. It could be all over the place. It does, in fact, go through at 29, so it should be like maybe up here somewhere. The turning point on these graphs are where I'm indicating. Now, how can we work those out? What we have to do is look at this completed square form and realize that on the left I've got a square number, and a square number, I mean, it's not necessarily, okay, so it's not necessarily a square number because x might be a decimal or something, but the point is when you square something, it's always positive. Like 2 squared is 4, minus 2 all squared is minus 2 times minus 2, it's also 4. So we get a positive thing here. The only exception is that you can get 0. If x was equal to minus 5, then this thing on the left would be equal to 0. And therefore, the smallest, like this. So what I'm saying is that this is always greater or equal to 0. And it gets bigger and bigger. That's what's going on here. These just get bigger and bigger. But if it's equal to 0, that's where the turning point is going to be, because it's when it takes its smallest possible value. And therefore, it's going to be when x is equal to -5, because that's going to make it give it its smallest possible value when I put -5 in here. And that's going to give me a value of 4 out at the end. So I basically pick this number as my minimum, okay, because it's always going to be bigger otherwise when I have this square. But what gives the minimum? It's when this thing is equal to 0, and that's when x is -5. So a long explanation of what we need to do. I think if you haven't seen this before, it takes practice, but if you have, hopefully that's come back, and that's how you can. It's a really useful aspect of being able to complete the square, that you can find out where the graph actually turns, which is in fact a very useful thing in mathematics.